so this time we're doing problem
from chapter 4, problem 47.
and in it says a 75 kilogram man steps off a platform that is 3.10 meters above the ground. He keeps his legs straight as he falls, but his knees begin to bend the moment his feet touch the ground. Treated as a particle, he moves an additional 0.6 meters before coming to rest. What is his speed at the instant his feet touch the ground? And what if we treat the man as a particle, what is his acceleration as he slows down if the acceleration is assumed to be constant? And C, draw his free body diagram. In terms of the forces on the diagram, what is the net force on him? And then using Newton's laws and the result of parts to calculate the average force his feet exert on the ground while he slows down. Express this force both in newtons and as a multiple of his weight. So,
Start off. So we have this platform with the guy who's, sorry. So we have a platform that is 3.1 meters tall, and we have a guy who's just stepped off, who has a mass of 75 kilograms.
So we want to know his speed the minute he touches the ground.
So for part A, we're going to use the formula. The velocity is equal to the square root of 2 times gravity times the height. So we know that, so 2 times 9.81 times 3.10, and that'll give us his velocity as he goes down. And so his velocity, when you do the math, comes out to 7.8 meters per second.
Part D wants to know his acceleration when he gets his feet just barely hit the ground. And for that one, we're going to use the formula that his velocity final minus his velocity initial, both of those squared, is going to be equal to 2 times his acceleration times the distance that he goes. So we know that his initial velocity goes to 0, so we don't have to worry about that one. We know that his final velocity is 7.8 meters per second, so that's 7.8 squared. It's going to be equal to 2 times his acceleration is what we're looking for. And then we know the distance that he moves once he starts decelerating, and that is 0.6 meters. We got that from the problem. So then we just have to isolate, so then the acceleration is equal to 7.8 squared divided by 2 times 0.6, and that is equal to, where'd it go? I forgot to calculate that one. So 7.8 squared divided by 2 times 0.06, that comes out to 50.7 meters per second squared. And so that's our answer for part D. Part C says to draw a free body diagram and then find the net sum of the forces, I believe. in terms of forces of the diagram, what are the net forces on him? So, part C, we have our guy. And this is just when he's just barely touched the ground. So, he's got his falling, his mass times gravity, and he's also got his mass times his acceleration. So that would be in the other direction. And he's got the force from his decelerating and his feet are pushing back up. The force of his feet. And so then what is the net sum of the forces? So we know that the forces net is going to be equal to his mass times the acceleration that is coming from his feet plus the acceleration of gravity. So that is going to be 5 times our answer from part B, 50.7 plus 9.81. And we calculate that out. 9.81 plus 7 is that times by 75. You get the net force is going to be equal to 4,538 newtons. And so then part D, I guess that is one of the answers to part D. Also wants that expressed as a part of his weight. So we take the force divided by the force of his weight. So divided by his weight will give us that expressed as a ratio of his weight. So we know that for his weight, that has to be his mass times the acceleration of gravity, which then comes to 735.7. So then we get 4,538 divided by 735.7. And that gives us our answer. So the force is equal to 6.16 times his weight. So I guess, and it's also that newtons is 453.8 newtons. And that's how you solve that problem.